Hello, hello, hello. Welcome to the SANS webcast, where we're going to be doing a preview of a brand new course. Very excited because it's a red team course. And as you can tell, I'm very red right now. I know a lot of you know me as purple, but you can't make purple without red. And I do go very much red. I am joined today with Jonathan, who's actually the author of this course. So he's going to be doing a preview here shortly. Before that, a couple housekeeping things. As usual, the number one question we get, is this being recorded? The answer is yes, of course, this is being recorded. The second question is, can you have the slides afterwards? Of course, you can have the slides afterwards. We will provide all of that for you. We are on Zoom and you've all used this before, so feel free to ask questions at any time. Normally when we have two folks here, we can answer some questions while the other one speaks. So without further ado, we have a ton of content for you, including demos and some very exciting stuff. So we're going to get to it. Again, my name is Jorge Orchilles, and we are going to talk a little bit about red team stuff today. And as many of you know, red teaming is a type of offensive operation. Many of you have begun this journey. I started this 15 years ago, maybe, doing vulnerability management and vulnerability assessment, learning and identifying vulnerabilities, calculating risk with things like CVSS. And then I proposed that we exploit those vulnerabilities, which means I started doing penetration testing. And we did that for a bit, and very similar to some of the journeys you've all done. But then we realized that the only way in is not through exploiting vulnerabilities. It's one way in, but there's a ton of other ways to do it. That's when we started talking a different language. We went from talking about common vulnerabilities and exposures, CVEs, to talking about tactics, techniques, and procedures, or adversary behaviors. And there we started emulating this. We realized today that one of the most efficient ways to start that is by doing purple teaming, which is the mix of red and blue working together. And of course, we have red team and stealth red team engagements. That's where we test the response of an organization, how they can detect and respond to a realistic attack, and of course, try to make them better. So I don't know where you are on this journey. Us here at SANS always want to provide you the most value. So depending on where you are, if you're just learning about vulnerability management, we have Security 460, great course to learn about vulnerabilities. We also have what I call the original purple team course, Hackers, Techniques, and Incident Handling. That is a 500 level course. Security 504 teaches you a little bit about attack, a little about detection and incident handling, really teaches you that nice, well-rounded intro, really, still, because it's a lower 500 level class in InfoSec. Many of you probably took this, so shout out to anyone that has the GCIH. And then you can kind of choose, do you want to learn about penetration testing? Because there's a ton of courses for that. Security 542 for web app, 560 for network pen testing, 660, which I know Jonathan teaches, is a little more advanced pen testing. And then 760 is one of our most advanced courses. If you want a more balanced learning opportunity, we have purple team courses, Security 599 and 699. And we are releasing a couple of red team courses. So I personally wrote Security 564, which was a 2-day course. That got turned into a 6-day, which is actually running right now for the first time. It's red team operations, 500 level course. You went to college or you've seen colleges, you know how the numbers go up. And today, and this is why I'm prefacing all of this, we are going to be talking about Security 670, a 600 level course on red team operations, focused on developing custom tools for Windows. So this is advanced. If you've ever taken SANS before, welcome back. You will see and feel the SANS fire hose effect right now. This is just a little section of the class, a little preview to get you interested in it. The class will be running its first run alpha phase in the coming months, and then will be available around Q3 or Q4 this year. So yes, the class, you can't register for it right now, but we want to get your feedback and see what you think so far. I've reviewed it and I'm loving it. So without further ado, I'm going to turn it over to Jonathan, our author and SANS instructor. You might have taken him before. He is awesome. Over to you, Jonathan, and let's do a little preview here.
Awesome. Well, thanks everybody for attending and registering for this webcast. I am super excited to give you just a little sneak peek into this class. I've been working pretty hard with this one, working for a little bit into developing this. And some of you may know that I teach 660. Maybe you attended 660 with me at the helm or at the podium. So thank you for taking 660 with me. So I'm going to continue to teach 660 and also 670. So I'm hoping to do 2 courses at the same time here. So that'll be fun to balance that. But for those of you that don't know who I am, let me give you just a little bit of background and where I came from. So right now, currently, I work for Lockheed Martin as a Windows kernel developer. I've been with them for a few years now. Just hit my 2-year anniversary, actually, I think on the 1st of this month. So that's been a lot of fun. Outside of that, I am in the Air Force with the Maryland Air National Guard. I have been in the Air Force for over 18 years now, and that time has just been flying right on by. And so I'm stationed at Fort Meade, and I used to do operations there at Fort Meade with Cyber Command and NSA. And then I switched over to do development, tool development, or as what Cyber Command likes to call capabilities development, cyberspace capabilities development. So I moved away from operations, went to tool dev to help enable the operators to do their job, to carry out their mission on target. All right, so I think that's a very fun challenge, a very unique challenge, and it's an awesome mission set that we have there with Cyber Command. But outside of that, just as a hobby, I'm into motorcycles. I used to have some sport bikes, used to race those on the track, never on the open road or freeways or anything like that, always on the closed track. And then I also like to get into like car detailing and stuff and polishing cars and stuff like that as extra hobbies. Family, been married for almost 10 years now, and I have 2 kids. They're 6 and 3, and they're quite a handful, that's for sure. But yeah, so that's enough about me and a little bit of my background there. So let me go ahead and advance the slide deck here a little bit and tell you about why in the world I decided to create a course like this 670, creating tools for Windows specifically. All right, so the first item is that, I have noticed, and also talking to many other folks, that this kind of stuff, offensive capability development, is not taught at university, not taught at like community colleges or even high schools, right? And so that makes a skills gap for folks that are trying to come on board, like at Mantech or Lockheed Martin, or even trying to join the military, like the Air Force, and become a developer or tool developer for the military. Right? So we had to figure out how in the world we can kind of fill in that skills gap a little bit. Well, on the Lockheed side, I helped create a 6-month-long pipeline where we kind of teach you how to do offensive cyber operations, leveraging C and C++. And I started creating this course before I joined Lockheed. And this is going to be a nice, like, 1-week kick, if you will, to really jumpstart that knowledge and get you on board for capability development for Windows endpoints. And from my perspective, there's just not a lot of courses that are publicly available to help you out with this. Like for Linux, for example, I've seen quite a few courses out there focusing on Linux and just overall C development for Linux environments, but really nothing geared for Windows. was like, why? So that's why I kind of wanted to create this course, and hopefully y'all get a lot from the sneak peek. All right, so this is just a table of contents of what we're going to hit for day one. All right, so day one, we're going to be throwing lots of labs at you. You can see on this next slide here, we have 8 total labs just in the first day. All right, so it's a lot coming at you pretty fast. And this is just an overall high-level roadmap of each day, what we're going to talk about. All right, and I'll get into these a little bit here, but my target audience for this whole course is somebody that is somewhat knowledgeable with C or with C++, whether that be for a Linux environment or if that's for a Windows environment, that's fine too. That's great. But for those that have been in Linux world for pretty much eternity, and eventually you're deciding, hey, you know what? I want to change a pace. I want to switch gears and move over to Windows, just not sure how to make that jump. Well, that's what this class is for. I'm going to help you make that jump, introduce you into some very Windows specific things, and we're going to dive deep into Windows internals, right? So I'm not just going to teach you how to create offensive tools for Windows, but also what is happening behind the scenes with the Windows APIs that you're calling or that you're executing to make a certain capability happen. And that way you can give that capability to an operator or for some red team engagement or something to go ahead and carry out their objective or their operation, right? And a lot of mature red teams now, they are having exploit developers and capabilities developers on staff full-time, creating capabilities that are custom for their organization, which I think is amazing. So hopefully y'all can get something amazing from this course. All right, so let me talk about in a little bit more detail about these different days and what you might see. So overall, I'm going to show you how in the world you can inject into other processes. Some of you might know this already if you have a little bit of a background on red team engagements, pen testing things, or just exploitation in general, what that means. But basically, we're getting into another process to either get shellcode execution, force it to load a DLL of some kind, maybe a malicious DLL that we coded up for a specific engagement or a very specific feature. We can also get into how in the world you can hide a process from a user or from a tool, right? And then we'll get into just how to hook some functions. I'll show you several different ways of how we can go about hooking functions and the purpose behind that, why you might want to do that, when you might want to do that, and some of the cascading effects of hooking functions. And on day 2, we can get so familiar with the Windows operating system that you're going to be like, wow, there's so much into Windows that I had no idea what was here, right? So we're going to really peel back and look behind the curtain as to Windows operating system internals and really start to get to know our target and start to do some like basically enumeration type of things. But we're not going to use existing tools. We're going to create the tools to do that, right? So from operational side point, once you get that initial access, what happens? You do recon, you do enumeration, and more enumeration, getting to know your target a little bit more and more and more. All right, but you're using tools to do that, like Metasploit or Cobalt Strike or Empire, Covenant. List goes on and on and on. You can check out the awesome C2 matrix to see all of the C2 frameworks that can help you do that. But what we're going to do is we're going to create some of that capability from scratch using C and C++. And then next, day 3 is going to be all about these operational actions. Some of the things that you can do against a target depending on where you're coming from and what your role is. So for red teamers, maybe you're just wanting to persist on a box. Maybe you want to try to showcase that you can exfil some kind of data like IP or something like that to show a vulnerability and show how the impact might affect operations or the stakeholders for a certain company. On the military side of the house, we have several actions that we can do based on the authorities that we have as the military. So we can destroy targets. We can disrupt, deny, degrade, and deceive targets, right? So that's, to me, that's a ton of fun. I love exactly everything that I do as a capabilities developer for Cyber Command. It's an absolute ton of fun. And of course, we're going at it with our peers, right? Other nation state actors, and they're trying to do, obviously, anything malicious that they can. They're trying to steal IP from U.S. companies like Boeing or Lockheed Martin or something like that to get fighter jet blueprints or anything that they think could give them a leg up over us. Day 4, we're going to spend an entire day talking about persistence. And so we're going to say, hey, you know what? We want our beacon, or we want our implant to die another day, right? We want to persist across those reboots. Again, we're not using tools to drop down persistence. We're going to create that from scratch, right? So I'm going to help you dust off any background that you might have in C, right? And if you don't know C at all, you're still welcome to take the course, but I'm not going to teach you how to create functions per se. What are for loops, if statements, stuff like that, right? So I'm kind of assuming that you already have that down packed before you switch gears and come on over to the Windows world, right? With persistence, though, when it comes to trying to protect your assets or your tradecraft or your tool, whatever word you want to throw in there, there's several different methods that you can do. You can go for something extremely simple, like just adding something to the run key. All right. And it's actually one of the most common methods used by actors today. And believe it or not, it's obviously very effective. And sadly, it doesn't always go detected quickly, but it could be letting them be on the box just long enough to bring down something more complicated or exfil the data or whatever they need to do. It's like a smash and grab. Get in, drop a run key, get your persistence real quick, and then get off the box for a little bit and wait for that to kick off later. Right? And then more complicated methods. Yes, you can get more complicated with your persistence, but basically what dictates that for you, right? So that would be basically, if you're a red team organization or red team tool developer for some company like Chase Bank or something, you would have to determine, okay, if I'm going for persistence, how complicated do I want this to be? Meaning, how difficult do I want it to be for blue team to find me? All right, so you can have the conversations with blue to say, hey, could you create a custom capability to test these various persistence methods based off the attack framework or something like that, right? So that's the beauty of creating these custom tools. You can have those talks internally or externally, depending on what's happening, and you can build out something completely custom to help the blue team out. And so that's awesome for like purple team stuff. And day 5 is going to be the most advanced day of the course. It's going to be the most that I throw at everybody and to throw at you. It's going to be how to enhance your implant, or how to make your beacon a little bit more feature rich, if you will. So we're going to talk about shellcode, how to create shellcode from C. All right, so we can use the C programming language with a combination of compiler flags, little tips and tricks there, and how to basically extract the opcodes from the text section of a compiled binary and use that as shellcode. All right. You don't have to be a guru in assembly and make something from scratch in pure assembly. If you can, awesome. I'd love to chat with you later. Might have a job for you. But in any case, we can use the knowledge that we have with some of the higher level programming languages like C, C++, and get our shellcode from there. Then we're going to get into evasion, How can we bypass and remain undetected by various personal security products like PSPs or antivirus products? Okay, so we'll take a look at Defender, Bitdefender, and Avast, and then kick y'all loose to like these boot camps of where you try to do the research on your own once I teach you some of the tips and tricks and just the foundations for how to do these bypasses, right? And then, of course, we have to call home at some point. So what does something look like? What does something like that look like? How do we call home? How do we get our implant talking to a C2 framework? All right, maybe you're taking an existing C2 framework like Sliver and you want to add more capability to it. So you have to understand how it communicates with the agents, and you can absolutely do that. And it's pretty amazing. Moving over to something about your environment, your dev environment. You have to test your tools. You have to know in a very strict test environment how your tool is going to perform on target. Your target should mimic the real target that you're going to be going after. All right. And so you try to get it as close as you can to that target environment, or that target of where you're going to drop this binary, where you're going to drop this implant. All right. That way, you know, with some high level confidence that your tool should not crash, should not alert the user to what you're doing, and should not crash the system. All right. Hopefully it wasn't bug check the system and get a blue screen. All right. So you're going to have to get really good at testing your tool and creating a very good testing environment. So we're going to get deep in the weeds on how to do that. One of the things I like to harp on for developers is think outside the box. All right. There's so much freedom that you have with code and with programming, right? You're basically limited to you and your knowledge of the internals of like Windows with what you can do. All right. So the more you get familiar with like the Windows APIs, the better you get at knowing what happens behind the scenes with Windows, the more creative you can start to become and ask questions like, what happens if I do this? All right. So what happens if I call this function and it's expecting this kind of thing and I give it something else? Or what happens if I do something out of order with a process creation, or, you know, a few other things like creating processes in suspended states? How much control could you have over a process that you create in a suspended state? All right. So we'll get a look at how to like hollow out a process and manipulate threads, hijack thread executions. All right. So again, being creative, you're basically limited by your own imagination and your time that you can commit to developing a tool. All right. So if you're coming over from the Linux world, you might be familiar with shared objects, right? Those shared objects are just DLLs on Windows. And if you're already familiar with DLLs, awesome, sweet. All right, they're still executables under the hood. They have a very specific structure. They have PE headers, just like a regular executable will have. There's minor differences between executables and DLLs. So this class is going to dive into the weeds of how to create custom DLLs and how to inject your custom-made DLLs into processes. All right, so that's going to be a ton of fun. All right, and then with shared objects, just a slide showing you some of the equivalents or some of the differences between Linux and Windows, right? So some of you might already be familiar on the Linux side of the house, how to get DLLs or shared objects loaded into a process. And we'll dive a little bit further into the similarities and differences between Windows and Linux. Something else that you might see when you're coming over from Linux to Windows will be data types. So Windows, for whatever reason, wanted to create their own data types. Yes, you can use the standard C data types like integers, longs, so on and so forth. But Windows, what they did is they created their own definitions, like these type defs to say int, right? Or double word or bool or LP void, which is basically just a void pointer. All right. These header files that you may have used with your C programming on Linux, you might be familiar seeing something like a pound include standard IO, those header files. Those are still available on the Windows side of the house. But then, of course, Windows had to create their own header files to be very specific to Windows. We have windows.h, okay, a very commonly used header file for Windows. You will probably include that into almost every project you do for Windows. All right, so there's going to be a ton that we're going to cover for the 5 days that we're diving into developing tools for Windows. Windows APIs. All right, so on the C side of things, on a Linux environment, you might know of a specific calling convention called cdecl. All right, so that's just specific to C. That's the standard calling convention for C. And in 660, we talk about calling conventions. For Windows, they wanted to create their own, right? And that is standard call. Standard call, and you're not going to see this on Linux ever. And it's just slightly different behind the scenes of how standard call works, right? There's still a whole right to left kind of push onto the stack with the arguments, but the difference comes into who does the cleanup of the stack for whatever arguments are pushed on. Okay, so cdecl, right? So if you're calling something like printf, it has variable number of arguments to it. Well, printf doesn't really know how many arguments are coming in off the bat. So whoever is calling printf has to clean up the stack. For the Windows APIs, they have these fixed arguments. So a fixed number of arguments. So it knows every time you call something like create process that X number of arguments are coming in. So create process can do the cleanup of the stack before it returns. Standard C functions will be available to you just like they were for Linux, but I would say in the end, a recommendation that I make is just use the Windows API equivalent. All right, so we'll get into how some of these are created. Like there's a function called RTL memcopy, which is just basically a macro around memcopy. All right. Cool, so that's a little wrap about some similarities between Windows and Linux. Diving down a little bit deeper into Windows data types. I mentioned before that you might already be familiar with some C data types like integers and booleans and stuff like that. But we're going to get into more specific Windows types like H instances, handles, P void and LP void. Is there a difference between the two? No, not really. They're basically just pointer to voids, void pointers. But they really mattered in the old school days for like 16-bit operating systems, right? So LP would just be long pointer and P void is just a pointer, a void pointer, right? So it doesn't matter which one we use nowadays. They're both the same thing today. And then you can see behind the scenes how these have been created. So they're type deft, right? So creating a new type definition like a word is an unsigned short. And then we have a double word as an unsigned long. And then you can see how we have that LP double word is just a pointer for double word. All right. On the Windows side of the house, it's great and recommended to use the specific Windows data types just in case the back end type were to change, right? It'll make it a lot easier for your program to adjust to those changes if that ever happens. But that hasn't happened since we moved from 16-bit operating systems to 32. All right, just a little example of how you can use some of those data types. For those familiar with getting a pointer to the PEB, we have these intrinsics where we can read offsets into segment registers so we can get a pointer to the PEB. And based on 32-bit or 64-bit architectures, you would use the FS segment register or like the GS segment register. Okay, some more data types. And for examples of how to use data types for like functions, that very bottom one there, like overflow me, is just a void return type for that. And it's calling stir copy buffer. Buffer overflows are in 660. Yep, they sure are. We're not doing any buffer overflows in this class. This is all going to be about programming in C, and we're not going to be doing exploit dev or anything like that. All right, that's done in 660. There are types for handles, believe it or not. You can get a handle to a registry key. You can get a handle to a process, or handles to threads, or handles to files on disk. Right? A lot of times you might think of those as like file descriptors in a Linux world. All right, so you can see how these are defined. Right? A type def p void handle, and then they just use that type all the way through for H key, H instance, and H module. All right, Win APIs and these callback types, these are kind of interesting because you'll see these a lot for how functions are decorated. The Win API is just basically standard call. So when you see an example like this, bool, Win API, enum processes, you can say that, hey, Win API is just a standard call. And we know exactly how standard call is gonna work, how things are gonna be cleaned up off the stack, so on and so forth. Right, so you'll be seeing this stuff a lot. All right, so that's a wrap for that little section right there. Next up, SAL annotations. Some of you may have never heard of SAL annotations, and awesome. I hope that's the case. Love them or hate them. For those that are familiar with Windows already, you're kind of like, really? We're talking about SAL? Yes, we're going to talk about SAL. All right. So these are useful to help other people coming in after you read your code and make sense of it. All right. So for like parameters, if you have a parameter that's read only, you can annotate that parameter as in, or if something's going to be writable, like an out pointer or something, you can say out. Or something that could be read write, you could use in out. And then getting a little bit further here is something like ret z. Okay, so saying that this particular function could return a null terminated value, perhaps like a string. Seeing an example of that is our create process API. This is a beast of a function, and you can see how Windows internally, they're using these SAL annotations to tell you exactly what's happening for each parameter. All right, so the application name, the very first one, is in, but it's optional. You don't have to provide it, meaning it can be null. Other things like the Boolean for inherit handles, that's required. Creation flags, a double word, that's required too. All right, and then at the very bottom, we have an out parameter. So we'll need some kind of pointer for the process information to go ahead and store that info. There are more advanced or intermediate levels of SAL annotations, right? So they can be much more complicated and very descriptive with what's happening. So a function could write out a bunch of bytes to a destination. All right, so what that looks like here is if you were to recreate memcopy, you could annotate the parameters with SAL annotations and make it a little bit less vulnerable, right, to overflows. Meaning, before you go to compile this program, if you had this version of memcopy in your code, Microsoft Visual Studio can do code analysis, static code analysis, and analysis on build. All right, so it's going to say, hey, I see that the destination, I'm going to write all bytes to the destination of size, right? So whatever the size parameter is, that's how many bytes are being written to the destination. And I'm also going to be reading in bytes from the source up to size. Okay, so this could be a way to prevent some buffer overflows. All right, it can do some pretty good analysis for that source code. All right, moving over to like a more intermediate kind of annotation and saying, hey, this particular API can return null. All right, so you're going to have to check it. And these are examples of some advanced annotations. You can also create like expressions for these annotations. All right, so internally, Microsoft is going to do stuff like this, like must inspect result, saying, hey, you know what, for using this API, you better inspect the result of this function, or else it's going to highlight it and give you like a little green squiggly or something inside of the IDE, Visual Studio. We also have one that can dictate what success might look like for a function. All right, and this is one more example of how internally Microsoft uses SAL annotations, and this one being outright bytes to, and it's optional, outright bytes to. Okay, cool. Just a quick introduction into Windows APIs. So for those that might not know how in the world Windows APIs are named, like the naming conventions, do they matter? A little bit, and you can break it down. Windows APIs are very descriptive. Some of them are incredibly long, which gets crazy to type out, but thankfully we have tab completion and IntelliSense inside of Visual Studio. But look at an example here. We have reg create key. All right, so we have reg, which is like the prefix, meaning we're going to be dealing with something like the registry. Then we have a verb saying we're going to create a key. Then we have like a target. All right, so the target being a key, a registry key, we're going to create one. So there's other ones like reg close, reg open, reg delete, reg create. Okay, so you can see how the verbs kind of make sense to what that API is going to do. And I think Windows APIs, the name is a little bit more descriptive than what you might see on the C side of things for Linux. These create APIs, what they're going to return to you a lot of times is a handle, right? The one exception to that rule, though, is the create process API, because it's a Boolean type. So the kernel is going to take that and say, hey, what process do you want me to create? Okay, cool. True, false. It's good. But that function can still fail. And we'll take a look at that of how in your code, if you're checking for the wrong thing, you might have disaster on your hands. Some more create APIs. We can create files. Create file can be used to not only literally create a file, but open a handle to an already existing file. That way you can read to it, write to it, delete it, so on and so forth. We can create directories. We can create threads. We can create events for like Windows events and stuff. And of course, we can create processes. All right. Diving down into the nitty-gritty of how create process is structured, how in the world you can call it with an example like this, just showing you how to create a notepad process from C. All right, so you can see all the arguments being passed in for create process. All right, there's obviously a lot missing from that, but just a very high level snapshot of how you could call a function like create process. Okay, yep, so again, you'll have all of these to download, so I'm going to cruise over a few of these and just show you some of the things I really want you to take away from this little webcast. One thing that we can do is we can give an operator, obviously, the capability to enumerate processes. You may have done that with C2 frameworks like Metasploit or Covenant or Empire, whatever, right? How does that work on the back end? What's happening when you say PS or PS list or whatever the command is to list running processes? All right, so it's doing something kind of like this. You're getting a snapshot of all current running processes, and then you can loop over that snapshot and print out to the console all the processes that are running. So this example right here is just printing off the name of the process and its process ID. All right, so let me try to jump into a demo real quick, and I'm going to show you how you can kind of get a kernel debugging session up and going real quick, and then I'll do another one of hiding a service. Okay, so I like to use WinDebug Preview. All right, some people are like, why in the world would you use that? I love the old school WinDebug or WinBag, whatever you want to call it. Well, I like WinDebug Preview mainly for its ability to do time travel debugging, or TTD. All right, so we'll show you how to do that in the course and some of the benefits of that. But let me show you how to set up kernel debugging. So down here, you can go to attach to kernel, and it needs a port number and a key. How do you get that key? All right, so on a target system, I went into a folder where I have this binary called KDNet. KDNet comes with the SDK, all right? And so let me go ahead and fire that off and show you how to use KDNet. KDNet will help you do kernel network debugging. So all I have to do is pass it an IP address and a port. So you need the IP address of the debugger, where I'm going to be debugging from, and the port. And then what that generates is a key that you can use. So that key is going to be passed in to here. As long as the port matches and the key matches, you can hit OK. All right, so it's going to go through and it's going to wait and wait and wait. And then it looks like, boom, there we are. We have connected remotely to our target VM, which is actually our test VM. All right. So some of the things that you can do is you can do process enumeration from the debugger. So let's say bang process 00. So that's going to go through a listing and give me back every single running process that it currently detects on the target system or the remote system. And a lot of times, depending on how many processes are running, this can take forever. All right. If it does, a lot of times you can break out of this. There we go. All right. And it's done. All right. Some of the other things that you can do is you can use a pretty cool new utility called DX. DX is a way to, display advanced expressions and stuff. And it's very, well, I don't know how exactly new it is, but I like using it in WinDebug Preview because they've added a lot of new capabilities for the DX command. So you can take a look at how many debugger sessions you might have. And of course, for this, we just have one. So I can get into that debugger session, show you a little bit more about that one, and then dive in deeper. Let's go ahead and see all the processes. Again, okay, this one's a lot faster than that bang process. And what's really cool about this one is this switch to. So for example, if I want to move away from my kernel context and get into a user mode context, I can just do switch to. And then boom, I'm already in that context of that process, and I can go ahead and take a look at the process environment block using bang peb. All right, so those who have taken 660 know a little bit about the process environment block and how important that is to each process. And in 670, we're going to dive so deep into some of these structures, you might get sick of it. All right, so that's just real quick, how to get a kernel debugging session up and running and some basic commands that you can issue. And then we're going to explore that so much more in the course. All right, so next up, this is going to be a bootcamp challenge in day 4. We're going to basically hide a service from tools like Process Hacker, the Task Explorer, PowerShell commandlets like get service, the SC utility, so on and so forth, right? So how does this work? And what are you going to have to do when you face this bootcamp challenge? Well, as you can see, I've marked this code up with a number of to-do statements, meaning I want you to implement all of these functions. All right. So the key ones will be like service hide and service reveal, service installer and uninstaller. So you can install the service and uninstall the service when you're done with it. Okay, so this is just a little teaser into the code that makes this happen. All right, so let's take a look at the compiled version of this and fire it off and see what we get. A little bit of lag here on this test VM here. Give me a second. Wow, goodness. All right, so it looks like that machine's hosed. I'll try to do a reboot real quick, see if I can get lucky here. How can you get back to the kernel? Meaning, how could I reestablish that kernel debugging session? So if that's kind of what you're thinking, how can I get back to the kernel or away from that context? You can just do a .context command to go ahead and switch to default context from your kernel session. Let's see how quickly this thing reboots. Yeah, yep, .context is what you're looking for there. And we'll talk about that specifically in the course. So you can do a .context and just hit enter. And it'll show you the context of what you're running right now. And then there's also like a bang process, a bang context, and then you can specify the address of the eProcess structure for a different process that you're looking for. All right, let's see if I can get back to where I was before. Yes, we're gonna fire off process hacker. Okay. CD into the tools and our day 4 bootcamp folder here. And let's go ahead and fire this thing off. If I could type. All right, cool, success. So it has successfully installed the service as not in service. Process hacker already told us that a new service has been installed. So I'm just gonna filter on not, okay, cool. So what that service did was create Notepad as system. Okay, so this could be anything you want. It could be executing your payload, executing a reverse shell, or anything you want, right? So we are the developers. We're coding this all up. We can have this service do anything we want for us, all right? So you can see Notepad has indeed been kicked off as system. All right, so we're talking about hiding, right? So this tool, if I give it the command line argument of hide, we'll go through and it will hide the service from view. So it's going to take process hacker a little bit to recognize that it's been hidden. So in the meantime, I'm going to fire PowerShell. There it goes. And it thinks that it's been deleted. All right. But it hasn't. It's still there. Our Notepad process should still be running. Hopefully. Maybe I spoke too soon. Okay, nope, it's still there. Okay, Notepad is still running. Now inside of PowerShell, let's see if we're able to hide this from the get service commandlet. Not in service. Okay, and it says it can't find it. All right, good. That's exactly what I wanted to happen. All right, so we have successfully hidden our malicious service from so many tools, right? Every tool. Okay, so how in the world could you bring this back? Okay, so there's a downside to this. You cannot stop your service. You cannot restart the service or anything while it is hidden. Okay, so you're gonna have to unhide or reveal this service to be able to stop it or restart it or take any other action that you might want against your malicious service. All right. So one of the things that you might have to do and learn is understanding this crazy syntax called SDDL. Okay. So we're going to dive into what in the world SDDL is, how in the world we can interpret all of this garbage, this nonsense kind of looking stuff, and basically give back the permissions for the service that we just hid from the users of the system. All right. Yeah, so pretty cool technique. This, again, is a bootcamp challenge for day 4, something that you are going to be doing and trying to figure out on your own. Yes, there is a translator. There's also APIs to help you do this. Let me go back to Visual Studio for a second here. All right, so let me expand my completed version for this. Okay, so we have as a string this service descriptor language, the security descriptor language, SDDL. We can convert that, right, with this crazy API, convert string security descriptor to security descriptor. Pretty crazy, all right? But all we're doing is making that conversion happen to something that Windows understands, or the service manager, the SCM, understands, opening a handle to the SCM manager, to the SCM, opening a handle to the specific service, and then setting the security for that particular service, right? And then if everything goes according to plan, you'll have success, and we should execute this statement here, right? So this is something that, again, you're going to be creating for a bootcamp on day 4. All right, so officially that's all I have. Real quick, down and dirty into kernel debugging, how to get it up and running, and then a little example of a bootcamp challenge that you'll face on day 4. What about unofficially? Unofficially, what do you mean? Unofficially about how to unhide services? Or understanding the SDDL syntax? Oh, officially, that's all I have for today. No, so no, I don't. Unofficially, I don't have anything else for y'all, other than the fact I hope y'all sign up for the course. I hope this was a good webcast for y'all. A nice little tease at what, just how deep we're gonna get into C. All right, so hope y'all ready for that challenge and ready to dust off some of those skills and kick them up another notch.
That was awesome, man. Mind blown. Some cool stuff. So yeah, once again, this class will be running in alpha and will be available here in Q3. So keep your eyes up and out. Follow us on Twitter. We generally post quite a bit on there. And of course, you will get a follow-up email here with the recording, with the slides. Jonathan went through 63 slides there and the live demo. Amazing. I had a little bit of doubt if he was going to get through it all, but he did. And that was awesome. Someone asked, where can we download the code? I don't know if you answered that one.
The code will come with the course. Right? You're creating the code. You're creating the code. So that's how you download it. But no, so during the course, though, if you get too stuck on labs or whatever, you're just beating your head against your desk, you can't fix it, the solutions to labs will be available upon request.
Yeah, and it is, again, a 600 level is meant to push you and frustrate you a little bit. Enough that you still learn, of course, but one of the best ways of learning is, taking your time and, maybe having a little bit of anger, but you direct that anger to the right thing and you learn. It's a great time. And if you've taken a 600 level, like 660, you know exactly what that feels like. But again, it looks like all the questions have been answered, Jonathan. Thank you so much for taking some of the time out here to show a preview of Security 670 Red Team Ops, developing custom tools for Windows. Thank you all for attending, and we will stay in contact.
One
Do
last
follow
thing.
Jonathan.
One last thing, if I can interrupt real quick. I almost forgot about it, but I want to show you the challenge coin for the CTF. All right, so this was just approved, the design yesterday, the other day. So this is going to be the coin for the CTF winners. I love this design. I think it's freaking sweet. All right, so I cannot wait to hand this out to the first team or the first CTF winners. All right, awesome. Back to you, George.
That was the best. Oh, wait, there's one more thing moment you could have possibly done, Jonathan. That coin looks awesome. Love it. Love both of it. I gotta take a second here just to stare at it one more time. That's awesome. So once again, thank you all for joining. We'll be in contact. If you want to hear more from Jonathan, he's on Twitter. I posted those up here on the chat, and we'll be in contact. Stay tuned for more. Thank you again, Jonathan, and have a great day, everybody. Bye-bye.